We have spent a lot of time graphing linear equations in slope-intercept form. So we have graphed using the slope of the line and the y-intercept of the line. Today, we're going to graph linear equations using both intercepts. So we don't have to know the slope today. We just need to know the x-intercept and the y-intercept. Okay, so this is going to be very simple. If I want to graph a line that has an x-intercept of 2 and a y-intercept of -3, remember these are two different points. The x-intercept, if it is 2, it has coordinates 2, 0. Remember, for the x-intercept, y is 0. And if the y-intercept is -3, that means it has coordinates 0, -3, right? The y-intercept has an x coordinate of 0. So I'm going to graph these 2 points, 0, -3. There's a point, 2, 0. There's a point. If I have 2 points, I can graph a line. So the line is not very good when I use my pen on the video, but there is a line that has an x-intercept of 2 and a y-intercept of -3. Okay, so you do this one, graph a line that has an x-intercept of 4 and a y-intercept of -1. Check your line, make sure it matches mine. Hopefully yours looks a little straighter than mine, but that is how you would graph if you were just given the x-intercept and the y-intercept. So we have been dealing for quite some time now with slope-intercept form, and slope-intercept form is y equals mx plus b. We know that x and y, that gives us the ordered pairs of points on the line. Every point on this line has an x coordinate and a y coordinate. We know that m is the slope, and we know that b is the y-intercept, right? So this is a useful form given the slope and the y-intercept. Today we're going to learn a second form of a linear equation. Now, someone is going to ask, why on earth do we need to know more than one form? Different forms are useful in different situations. So sometimes standard form, which we're about to learn, is going to be a good way to go. Sometimes slope-intercept form is a good way to go. They each have different places where they're useful. And what standard form looks like is capital A times x plus capital B times y equals capital C. This is how standard form is written. Standard form is sort of a more formal form. Every type of equation we're going to look at through the year has a standard form, and that's just sort of the fancy, stuffy one. Notice it still has the x and the y, right? Only they're on the same side of the equal sign. In slope-intercept form, they're on different sides of the equal sign. In standard form, they're on the same side of the equal sign. This A, B, and C, we can get information from them, and we're going to do that, but just looking at A and looking at B and looking at C, they don't really mean anything, okay? A and B are coefficients. A is the coefficient of X, B is the coefficient of Y, and then C is a constant, okay? Now, where standard form shines is to be able to find the intercepts of the line. We've already done this. We just didn't call it standard form. So they're going to give us an equation in standard form. We're going to find the x-intercept and the y-intercept. We did this in the previous video, and then we're going to graph the line using those intercepts. Okay, so I have 8x minus 4y equals 16, and it says to graph it using the intercept. So I need to find the x-intercept of this line. And remember, the x-intercept, the y value is 0. And if the y value is 0, if this is 0, this goes away, right? So I end up with 8x equals not 18. 8x equals 16. I'm going to divide both sides by 8. And my x-intercept is 2. So remember, that's the point 2, 0, because we let y be 0. So I'm going to put a point at 2, 0. That is the x-intercept of this line. Next, I'm going to find the y-intercept. Remember, with the y-intercept, x is 0. So if I were to let x be 0 right here, this would go away, and I'd be left with negative 4y equals 16. So I'm going to divide both sides by negative 4, and I get y is negative 4. So since that's the y-intercept, it has ordered pair 0, negative 4. So 0, negative 4 is my y-intercept, and I can draw, presumably, the line through those points. I really wish I could figure out how to do that better on this tablet thing. So there's my line. Now remember, we talked about lines having names. We could say out beside or on top of this line, 8x minus 4y equals 16. That's its name. You don't always have to give it a name, but sometimes you will see that. Okay? All right. So my next one is 6x plus 3y equals negative 6. I want you to find the x-intercept of this line. Okay, so when I'm finding the x-intercept, y is 0, so this would be 3 times 0, which is 0, and I'd be left with 6x equals negative 6. I divide both sides by 6 and get x equals negative 1. So negative 1, 0 should be your x-intercept. If that's not what you got, fix it so that you have it correct, okay? Now, next thing is to find the y-intercept. So find the y-intercept of this line. All right, when I let x be 0, this goes away. I'm left with 3y equals negative 6. Y is negative 2, so my y-intercept is there. Then we want to draw the line through those 2 points. Your lines will look so much better than mine, and that is the line 6x plus 3y equals negative 6. Okay, next equation, x plus 2y equals 4. So first, find the x-intercept and graph it. You should have gotten 4, 0, because the x-intercept, y is 0, this would go away. So I just get x equals 4. I didn't even really have anything I had to solve, right? Okay, so fix that if you need to. And then next, I want you to find the y-intercept of this line. For the y-intercept, x is 0, so I get 2y equals 4. Divide both sides by 2, and the y-intercept is 2. So the y-intercept is 2, the x-intercept is 4. Draw a line through those points, and that is the graph of this equation. Let's do one more, okay? So 7x minus 7y equals 35. So I want you to find and plot the x-intercept. I got the point 5, 0. If that is not what you got, correct it. Make sure you understand how to get it. Next, find and plot the y-intercept. I got the point 0, negative 5. So those may be, and this is not saying much, but those may be my best 2 lines yet. So I have this line, and this is the line 7x minus 7y equals 35. Now, I hope you see that we've done the x-intercept and y-intercept. We could find the slope of all these lines, right? So this has, what is that, 5 over 5? So the slope of this line is 1. This line would be what? Negative 2 over 4, which would be negative 1/2. This line has slope negative 1/2. So we could still find the slope here. We could write the equation in slope-intercept form. There's lots of things we could do, but our focus right now is just finding that x-intercept Y-intercept, and graphing the line.